Thanks for coming to my session, one of the last. I'm having a great time. I hope you're having a great time too. I'm also an ambassador for Codemotion, and I've the honor to help them organizing this during the whole year. So it's quite a thing to see what they achieve in such a short time and with such short with limited resources. So I'm going to talk about DevOps in a serverless world. So I'm going to share a thing with you. How to get accepted at conferences like this. First, be an ambassador. Second, work at Microsoft, because apparently it's if you put technical evangelist in your title in Microsoft, everybody wants to hear what you have to say. Second, use a title with not one but two hype words, DevOps and serverless. And I could have chose other titles like All You Need Is Code, or Look Mom, No Servers. The disappearance of servers, that's David Copperfield right there. Instead, or I could have chose better DevOps through serverless, because operation is not going away. I will make a point that serverless, in fact, enhance the adoption of DevOps in any organization, really. That's me. Hello. I'm here because I like technology, not because I work at Microsoft. And you can find me there on Twitter. Is a very strange Twitter handle. It's not on sale. You can fill a survey. There's a link in there, a QR code. I'll keep my talk very much agnostic. I'll do my best. But I work for one of the big vendors, so please excuse me if I sometimes talk too much about the Microsoft version of serverless. It's what I use every day, so it's not my fault or anything. In fact, I want to give people two balls. So if my talks becomes too much sales-oriented, you are authorized to throw me the ball, and I'll stop immediately. So what is serverless? So I want to share with you this feeling that I have, and it's a rather weird feeling. Sometimes, does it feel for you that IT is becoming so complex and so awesome? Every day that passes, there is a new thing, and you can't keep up with the pace. You can't keep up with the innovation, right? And I guess many people in the room and many people in the industry share the same feeling. I have the same feeling. I feel like I don't have enough time. 24 hours is definitely not enough to know everything about this and everything about everything else. It's interesting. So we also live in this world where, I don't know you, I'm 41. I look younger, but I'm 41. And for me, there was a time before DevOps, and there was a time before cloud, and there was a time before all this. But think about it, there's a new generation that that's the only thing they know. That's the only thing that they see is cloud, and even the younger people, they only think of serverless. They will think, what is a VM? What should I do with a VM? I don't really care. So we are in this very interesting moment where we are accelerating the paces of innovation. That's why we have to reflect. We have to maybe slow down a little. We have to process the innovation and do something cool with it. So what is serverless? So everybody knows, and I was there when everything was on-prem. There was no internet even. There was no connection. There was only one big connection at the university, and everybody went there to connect to the internet. But this is what happened in the last, let's say, 10 years in computing. Since Amazon opened the very first public cloud in the world, we are accelerating towards a less bulky and more agile way of doing computing. So we are along this line, and maybe I will also show you what can lie next. Of course, nobody knows, but I'll do an educated guess about it. So another hype word is microservices. Everybody heard about that. So let's say you are one of these big incumbent or big corporation where you have a big monolithic application, and you heard that there is a thing called microservices where you can split stuff. You can split services into their own little containers, possibly Docker containers, and they all talk the same language, which is REST and HTTP. So you put them into their own boxes, right? So it's all nice and dandy, and the 12-factor app concept. very successful. People use it everywhere. It works better. It gives you more agility, better code, more isolation between failures. It's all good and fine. But some people then thought that maybe we can also get this to the extreme and move stuff around and put every single function. What is a service? A service is a entity that does something with data or does something with your customer information or process things like a cart or a database. So inside that service, there is more code, right? There is probably a few hundreds of lines of code or even 1,000. And they all make something different, right? Every function in the code is a specialized function, specialized purpose. So why don't we put that? Because if I'm doing containers or if I'm doing microservices, I'm still managing something like OS or even Docker containers. I still have to manage the base image I'm pulling from or what framework I'm pulling in, PHP 5 or Python 2.7 or 3. So it's still some friction towards the complete this nirvana of not managing anything but your code. So let's say you split your code in snippets, in little units of, and you call them function, and you squeeze them in, you send them to your cloud or to your, there are also non-cloud ways to deploy this, I'll show you later. And now you have the perfect architecture for this, which is, you separated all the components into each individual function. Think about it, it's quite revolutionary because now you can observe, it's like live debugging of your application, of your service. You can observe which function is called the most, which function is the slowest. You can do very much better insight into your application, your service, and because you are now decomposing your code into individual parts. So this was introduced by Amazon with Lambda 2 years ago, something like that. And of course, all the cloud providers catch up with that. Microsoft, Google, and a bunch of open source projects came along. I'll talk about later. So what is serverless? So what I just said is you abstract from servers, you abstract from framework, you abstract from everything, and you leave the bare code to be executed. This code is executed when there is an event that triggers it and can scale indefinitely. So imagine we at Microsoft, at Google, and Amazon, they have all this underutilized infrastructure that it gives you the possibility to use it and run your code on it. You don't see what's going on in the background. You don't really care. But you are tapping into this potential pool of computing resources with just a click of a button or just pushing your code to the cloud. So it's nothing new, really. We've been doing, let's call it diskless computing or diskless storage for many years now. Think of S3 or blob storage for Azure. It's effectively an infinitely scalable pool of storage. And this is something similar, but for computing. So for CPU cycles, for RAM, for all the computing resources that needs to be there when your code runs. And this is where I think, and this is like, what is DevOps, right? What is serverless computing? You ask 10 people, you get 11 answers. Serverless computing is pretty much the same. There's no consent on what is serverless computing. I have my own opinion. That includes the fact that serverless computing is usually built by consumption, which means that every execution, the cloud provider charges you a very little fraction of $1 or of €1. But I think it's the critical difference between the old way of doing PaaS, platform as a service, the old way of doing infrastructure as a service, where you commit to a fixed amount of resources, even for a minute or for an hour, but you're still committing to pay that, even if you are not using it. And the the real difference here is that we charge you only for the CPU and the RAM that you are using, and nothing else. Sometimes we charge, some clouds charge for traffic, of course, but that's irrelevant. So it's this really, for me, the differentiator of serverless computing towards the old way of doing things like FaaS. So the benefits, reduce DevOps. I didn't say no DevOps at all. If you look at serverless just to fire your operation department or all your operation team, you are deluding yourself. So serverless is not about reducing operation. It's more about reducing wasted operation or wasted time in non-business critical activities. So but that's why it's so popular now. It's so popular, or should be popular. You should think about it because it gives you the chance to think about your operation, throw away all the things that are not necessary to your core business, and just focus on what is important. Which most of the case is the code, but also what goes around the code. It doesn't let you get away without monitoring or auditing or authorization, authentication. It lets you focus on important things. That's a big difference. That's why, so you can focus on the logic of your application, you can focus on what's important for you, and don't waste time patching servers. And I did my fair share of OS patching and deployment, and it is fun up to a point, and then it just becomes old. And there's all this because this is the age-old DevOps idea that we're all here to deliver not code, but value to customers. Because if we don't, our competitor is going to do it. So this is just another tool. Serverless is just another tool in your tool belt to do what you should think is best for your customer. So I don't see. We will talk about the bad things about serverless. So these are your servers, big old iron. Just throw it away and replace it with functions. So it's an abstracted delivery model for code. So that's what it's also a bit of a lot of fancy words in there, but it's just that it's a way to deliver code to your cloud to run it in a different way, or without thinking about which VM I'm deploying to, even without thinking about which Kubernetes cluster I'm deploying to, or am I using Kubernetes or Swarm or whatever. I don't really care about that anymore. That's my application, that's my code, please run it, and let me know if there's a problem. That's basically how it works. It's scalable, and it's one more step in the unstoppable trend of outsourcing business problems that are not critical. That's what we all do with cloud, right? We don't need to manage our own data centers anymore because Microsoft or Amazon is doing it for us. So it's basically outsourcing, just that we call it cloud or we call it in a different way, but it's really just that. Just giving my problem to somebody else in exchange for money, and sure, most of the time it's even more expensive than solving yourself, but your time can be spent much better in focusing on the business than just patching Fedora or Debian. So we go from microservices, which still are one logical unit of action, and instead we decompose this into even smaller units of code that does one thing. It actually reminds the Unix philosophy. One command does one thing only, and don't put too much in one command. So like ls does only listing of a directory and so on and so forth. That's why people hate systemd, and I'm not gonna start a flame war about systemd now. So this is what people think of serverless. So Patrick Debois, one of the first DevOps guys, or one of the who invented the word DevOps, made a Twitter poll, and I voted for the second one. But most people think of serverless as a way of deploying code. That's their way. So one more reason to use serverless or to use ways of optimizing, because all this is very convenient for your cloud provider, for you as well, right? But we, and I'm putting myself in there, I work for a big cloud provider, we also make money out of this because we can optimize in the background, behind the curtains, what's going on. So we scale this so efficiently. Most cloud providers, they build their own servers, they build their own routers and switches, because it's economy of scale. But this has a side effect, and for who was at Ankuri talk yesterday, she talked about this. So better utilization, better efficiency in the cloud or in your own code will eventually bring the advantage of using less to do more, right? And that's what we should all strive for, despite recent elections, but we all should really care about the planet and the environment, and we should really think that every 10% of more, or if you can squeeze more stuff, more containers, or more application, or more code into one unit of computation, you can use less, and then you can, save fossil fuels or whatever is used to run your cloud. So that's all nice, but there's a dark side. So we'll talk about this is confusion, right? I mean, people approach serverless without really an understanding of what can they do with it or what to do with it. So I hope the talk gives you a bit of more insight. So let's not confuse serverless with a PaaS. So serverless, is actually, for me, is a stripped-down version of a PaaS. So the PaaS is always opinionated, right? So take OpenShift, take Kubernetes, take Cloud Foundry. Gives you a very specific way of deploying things or running things, service discovery, DNS, you name it. It's really something that you have to buy into fully, and then you can use it, and then it works great, but it's still a big of a lock-in. Instead, serverless is just the little code that runs somewhere, and you take care of everything else. So it's, I think it's a stripped-down version of PaaS. Please come to me after the talk, and let's discuss it. One thing that is not, and it's very important, is not, in the beginning of DevOps, there was this idea of getting so good at automation, getting so good at configuration management, for example, that we would need no operation, really. That's, it didn't happen. I don't think it should happen, and I think it's not gonna happen, because operation is it's about your own business operation. So if you prepend with business, that it makes all sense, because this is really what is ingrained in your processes, what the people believe in your organization to be what it takes to run your business. You don't want to outsource that. You don't want to outsource that part of your business. You want to keep it very close, because that's your secret sauce. It's your magic, right? It's how you run things. So if you look at serverless to eliminate all the operation people, that's not going to happen. And it's not, of course, it's not limitless. There's no such thing as limitless cloud computing or computing resources. So you have to take care that that when you run it, you understand the limitation of the system. You understand that the function takes some time to start and to roll and to cool down. And it's definitely not, as much as containers, a way to break free of lock-in from your cloud provider. And I say it with no shame. I mean, I work for one, so, and I think if anybody that sells you this, it's not really fair. So once you run your function, it's all very nice, but functions are not living in isolation, right? I mean, the function that you deploy probably is going to talk to a database. Actually, you should save the state of your application in a database. So, because serverless are also stateless. They don't store anything. They are ephemeral. Whatever they are computing about is going to go away unless you save it somewhere. they probably want to talk to a message queue, they need storage, they need a database, they need a lot of things around. They need an API proxy, they need a load balancer, who knows it? And all these things are where all cloud providers are slightly different from each other. Try to spin up a Elastic Load Balancer by using the Azure API in Amazon, it doesn't work. So that's where you are locked in your cloud provider. So now that you know, you should think about it and don't do it. Just try not to get too much dependent on cloud services. And there are ways to do that. So that's what I talk about. So there's no ops, but there's invisible ops. There's what you don't really see, but it's there, and it's very important for you to run your business. Another myth, serverless is not free. I think it's a bit like heroin. Cloud providers are giving you free stuff, 400,000 API calls for free in Azure or Amazon. Maybe Amazon is a million. So it feels really like a pusher trying to get you hooked up on some stuff, right? So, but this is how you should see costs of your operations versus the complexity of your application. So VMs is the blue line. They go up in discrete increments. And serverless is the yellow line, goes up from a point just monotonically up to wherever you want to bring it. So you might be victim of your own success. It's good in a way because it enables you to get innovation. So you are a startup, you have no money, and you don't want to raise VC funding, like yesterday Mike Lee was talking about. What you do? You go to Amazon, you go to Azure, you build your mock-up, or you build your minimum viable product, you build it with serverless, you pay nothing until somebody starts to actually use it. And then as they use it, you have to always keep this in mind, and maybe, just maybe, it would be more convenient to move some workloads to a more stable or more constant pricing model like VMs, and keep some stuff in serverless wherever it makes sense. So it's not always good. So like this is a technology. It solves problems, creates more problems, and you can't just throw it at problems and pretend that technology will just make you smarter, or it doesn't make me smarter. So let's keep it this way. A bit of pitfalls. I have 10 minutes left. So cold start, it's a thing that, so function they run on server. There is no cloud, it's just somebody else's computer, right? So there's still a computer, a server somewhere that runs your function. It needs to be prime, it needs to be warm up. There are ways around it. Ecosystem lock-in I talk about. Don't use serverless for long-running processes, because most of the cloud providers will kill your function in flight. And security is a whole kind of worm that I'm not going to even talk about today. But please come and come talk to me about security in serverless. I have 10 minutes, so that's how it looks. So most of the time, at least in Azure, we decide to have this model of having code with an input, a trigger, which triggers the execution of the code, and then an output. So it's really like a simple model to think what code does in your application. How does it look like in the actual deployment on your machine or in the cloud? It's just a couple of files, and it's just a web application, really. So host.json contains some parameters, proxies contains how to proxy the serverless application, and then just the functions are whatever language you want to write into. And in case of Azure, that's why I'm showing this, because that's what I know. I'm not sure about everything else, but at least that I need to show you something. So you can actually have polyglot functions apps, which means one app, which is like a collection of functions. They can all have their own triggers, inputs, whatever. But they can be written in whatever language you like. We support a bunch, and wherever we don't support, we can execute binary code. And we're going to add more support for more languages in the coming future. So I know it's far, and you can read it, but that's how it looks like. So the function JSON is what defines the inputs, the trigger, and the output. It's simple as detection out, detection in, and the trigger is this one. And that's the function. This is C#, so don't ask me what it means, but I guess it's logging some stuff upon, let's see. Yeah, so this is a webhook. So there's an endpoint generated by the cloud provider. You hit the endpoint, this stuff gets executed. So simple as this, but very powerful. And that's, so some application of it. Maybe you're already thinking of it, so you can start something every now and then, every 15 minutes. So let's say scrape or clean database data. You can start a process, start a computation process based on, for example, a file added to storage. So you can do something on the file itself. You can use the presence of the file as a trigger and the file itself as an input, and then the output can be whatever, JSON for Power BI or something else. Let's say you have a software as a service, you have a web app or something, and you upload a file, same thing. You can analyze the content, you can take a picture with your phone, and actually one of the next examples, so let's not run ahead. So let's say you have a page and you have somebody registers, you have a function for that creates, for example, a user profile, or populates a profile with a predefined set of data. You can use it as mobile backends. It's pretty straightforward. Same thing, you take a picture with your phone, a function will be triggered by that, and you can do something with the picture you just took, send it to connected services for analysis, to morphing, whatever you think, or scale the picture in different sizes. Very classical application of serverless is to create bots, right? So bots are just, they pretend they are people, they are not, but they respond to stimuli, and the stimuli, and this response can be a serverless function. It doesn't need to be a long-running app that runs in Azure Web Apps or whatever. It can be something that is just called on demand when you talk to the bot. When nobody's talking to the bot, there's nothing running, there's nothing going on. The function is there, waiting to be triggered, but nobody is triggering it. So you can use intelligence as well. Bots are intelligent now. We make them intelligent. Maybe it's a big mistake. So an architecture of a serverless function, I'm going to skip all this. The idea is that you can use the tooling that you already use, editors, most of the time, I guess. We have one. I have one favorite editor, but you can use anything you want, and then push it to the cloud or develop locally. You deploy it, classical thing, continuous integration, continuous delivery, continuous testing of serverless applications. Serverless applications are applications, so it doesn't let you off the hook to not test your application before deploying it to production. So nothing very new there. Monitoring is really not, again, not something new, right? I mean, if you don't do monitoring now, you're already doing it wrong. Servers won't help you. You still want to get insight in your application and act upon that. 5 minutes left. So do you need cloud for that? You don't, actually. So it turns out that most of these frameworks are open source. Even Azure Function is based on the WebJob SDK, which is on GitHub. You can download it, run it locally. And there are a bunch of projects out there that turns for example, your container orchestration into a serverless platform. So DevOps, because the talk had the hype word DevOps in it, so that's where we are. So I started there, right? So DevOps in the beginning was all about configuration management. It was all about Puppet and Chef. And I can create a VM in Amazon and just turn it into a web server with Chef. Great, nice. Then it was all about those containers, right? It made it even better, even faster and stronger and more secure. I think it's more secure. But we didn't stop there. Actually, I'm proud of it. We didn't stop there. Now we deal with with serverless and function. What triggers this change? And there was a video of a rabbi about change, and it's very interesting. So like lobsters they grow inside their shell, and the shell is fixed. And when they start to feel uncomfortable, when the shell gets too small for them, they actually grow. So they can only grow if they feel uncomfortable, if they suffer, if they feel the pain. That's what triggers growth and change and becoming a bigger lobster and an adult lobster. So it's just resonated with me. So DevOps is changing. So we need to adapt DevOps to this because this is happening and we can't live in the past. And in fact, like DevOps people that I talk to, they are the agent of change in most organizations, right? So they are the ones that take risks. They are the ones the cowboys that deploy stuff without really thinking of it, or that's me. But most DevOps people also think of stability as well. But that's why you only live once. You only have one opportunity at this, so you have to capture the wave while it's running and don't stay behind. So there's an opportunity in here. DevOps can lead this change or let it led by. So there was a time for a demo, but I decided to skip it because the screen is far and didn't have much time. I almost ran out. And I want to talk about a few more things. There's a demo made by Microsoft because that's what I deal with, and it's about a simple serverless application. It's on GitHub. It's on this URL. I'll give you the slides later. So what next? So now we have this beautiful. So we have this new paradigm, right? So we went for a paradigm to another one. Now we have this one. So what's going to happen next? So the great thing, so this is we talked about this at Build. It's a conference from Microsoft a couple of weeks ago, which is called Edge and Distributed Computing. So let's say you have this, you wrote these functions and you run them in the cloud, and it works. But what about you want to develop locally? And by the way, we made a thing, because the frameworks are open source, you can run them on your own laptop. So you can run functions locally, develop locally, and send it to the cloud. And it works. But imagine you can leverage this edge computing, this distributed model, where you bring computation close to your customer, close to where it's needed, close to where you have resources that you don't use. So that's the idea behind distributed or edge computing. Think of SETI, you know, the SETI project where everybody could run a screensaver and help finding extra aliens, right? Think of it and apply it to modern application development. You can take the code and execute it at your customer unused desktop during the night. Or really, if you think of IoT cases, you can take that code and execute it very close to the IoT device, so you don't waste time, you don't waste back and forth data exchange between the cloud and the devices itself. So it's just a thing that I wanted to put it there, so innovation doesn't stop. Maybe we are not yet feeling uncomfortable like a lobster in serverless computing, but it may come, and when this comes, we have to replace that with another paradigm, with another model. So, is it for you? I don't know. You have to answer yourself, and always keep cost in mind. Always keep an eye on your bottom line, your customer satisfaction. The thing is, do you really care if Netflix, the movie you want to watch on Netflix come from Amazon or from Azure or from whatever? You don't care. You just want to watch a damn movie, right? So you have to think that this is a technology that helps delivering value to the customer, but it's not all about technology. It's more about the value than the technology itself. So think about it, think your bottom line, and if it's for you, then let's get the party started. You know how, you can talk to me, can talk to one of the cloud providers out there. They all have an offering about this, and they will be very happy to help you. And me as well, I'll be happy to, hear your stories and try to get there. So that's how you get started. You go to, my employer and subscribe. So I'm doing quite OK with time, so there will be time for questions. So let's make DevOps great again by using serverless computing. Questions?
Hi. Hi. When you talked about not long running operation, what were you talking about? About minutes, hours?
So cutoff, I can talk only about my own experience. In Azure function is 5 minutes. So everything that runs longer than 5 minutes is going to be killed eventually. Okay. And you cannot change that. It's not a way to discuss it or to make a deal with your cloud. Most cloud providers don't do that. You have to take it as it is, as a black box. Is a same default, at least we think it is. If you have to run longer jobs, serverless is not the way to do it. There are ways to do it. That's the compromise. We don't leave you alone. We just give you another way to do it.
Yeah, but then you pay much more.
Sure, but are you sure? Because
otherwise you need to set up a worker role or something like that. But then you, as long as worker role is in the place, you pay for it.
Yeah, but so function is charged per 100 millisecond unit.
Yes.
But how many 100 milliseconds are in 5 minutes? A lot. So maybe I'm not saying that this is the case, but you may as well save money by running workloads that don't fit the serverless model somewhere else.
No.
Hi. You talked about spin-up time. What time are we talking about here? Milliseconds, seconds, minutes?
So when the function is warm, that's really sub-milliseconds or because they are already idle workers ready to execute the code. But if you have to start cold, that may take quite some time, and it can be surprisingly long for you. So you're sitting at your testing, or you're looking at the web page, and things are not there, and it's quite annoying for customers. So it may take even minutes. It all depends. The thing is, somehow it's a black box. So we understand that's not exactly pleasant, but it is a black box. The underlying systems are not known, and that's the way it is. So I've seen up from completely cold, when you deploy a new function, even a couple of minutes before it's actually starting to do what it's supposed to do. But it may take even less, depends on many factors, the framework. And of course, we offer tiers of premium, and so they're all different. So.
Thank you.
No more questions? Okay.